Stuck on CNA labs? Tired of scattered tutorials? This full course covers every exam topic with real lab configs. Grab your free lab in the description. Ready to pass CNA and boost your career? Start now!
Hello, This lesson covers physical media. After completing this chapter, you should be able to classify network cables. Second, master how to make twisted pair cables. Third, learn some general knowledge in network engineering. This lesson has 3 main modules. The first is about copper media. The second is about fiber optic media. The third covers basic network engineering knowledge. Let's start with part 1. Copper media. Copper media, by type, can be roughly divided into 2. The first is coaxial cable. The second is twisted pair cable. You might be unfamiliar with coaxial cable. Older students may have some life experience with it. This coaxial cable is actually the signal cable used for cable TV on our old televisions. White on the outside, with a copper wire in the middle. Both ends need connectors. One end plugs into the wall outlet. Right, the other end plugs into our TV. This includes satellite dishes. Right, the cable coming out is also coaxial cable. In current network engineering, coaxial cable is rarely seen. The only place you might still see it is in some security fields. Like in surveillance camera setups. They might still use coaxial cable. In our data communication field, like enterprise networks, coaxial cable is rarely seen. So just get a basic understanding of this. Our focus is twisted pair cable. So-called twisted pair cable is commonly known as network cable. Network cables, by function, can be divided into UTP and STP. As you can tell from the names, the main difference between them is whether they have shielding. Right? At the same time, you add a shielding layer. Right? So its manufacturing cost will definitely increase. Therefore, when purchasing these cables, their prices also vary. Let's first get a brief understanding of this coaxial cable. You just need a basic understanding of it. In its center is basically a single copper wire. Then, on the outside then comes the shielding mesh. And then outside is a protective jacket. On the outside is a layer of, right? Then on both ends, use our connectors. And just screw them on. Connect both ends to our interfaces. This coaxial cable, can then be used. This is relatively simple. At present, coaxial cables are basically facing obsolescence. Our key focus will be on shielded twisted pair and unshielded twisted pair. Unshielded twisted pair cable is called UTP. Inside it, there are a total of 8 copper wires, each covered by corresponding plastic insulation. Then on the outside, there is a single overall outer jacket. Of course, besides these 8 copper wires. If you have ever handled network cables, or made network cables before, you probably know there is actually a white cotton-like string inside. Right? This string, some people call it an antipole thread, a tensile, others call it a ripcord. Actually, any of these names is fine. You can call it, generally speaking, according to the manufacturer's manual, it's called a ripcord. It's the string used to tear off the outer jacket. A cotton string for ripping it open. When we make network cables, we need to take this white cotton string and cut it off. Just cut off the exposed part. Then, inside, there are 4 pairs of wires in total. 4 pairs inside. Yeah, 8 wires, 4 pairs in total, right? Then every 2 wires are twisted together. As for the colors, they also have different identifiers. This makes it easier to attach the connector later. We call it an RJ45 connector. When crimping the RJ45, there are different wiring sequences. You must memorize these. As a network engineer, crimping RJ45 connectors is a fundamental skill. Right. Compared to UTP, shielded twisted pair cable has an extra shielding layer. It has an extra of course, this also depends on the cable specification. Depends on the cable spec. Generally speaking, Our network cables, based on the data bandwidth they can transmit, can be divided into many categories. The most common ones are Cat5e and Cat6, Cat6a and Cat7. These are relatively common. Categories like Cat5 and below, Cat1, Cat2, these categories are basically not used anymore. Right, what you can see nowadays, basically. At the very least, it should be a Category 5 cable. The transmission speed of a Cat5 cable can reach 100 megabits per second within 100 meters. Starting from Cat5e, it can transmit gigabit speeds and above. Of course, this is also a theoretical value. It needs to be analyzed based on actual conditions. It's not guaranteed that Cat5e will definitely reach this gigabit speed. That's not guaranteed. Generally speaking, for Cat6 and above, Cat6, Cat6a, Cat7, these cables have added shielding layers. Especially starting from Cat6a. We are able to transmit 10 gigabit bandwidth. To transmit 10 gigabit bandwidth, the electrical signal frequency is very high. You should have learned in physics that electricity generates magnetism, right? When electricity flows through a conductor, it generates a magnetic field. When the electrical frequency is very high, it creates a high-frequency magnetic field. This will affect an adjacent cable. It will affect an adjacent cable. Inside that adjacent cable, there is also electricity flowing, right? It is also generating a current. At this point, mutual interference occurs between them. The magnetic field might affect the adjacent cable. This can cause our transmitted data to become distorted or be damaged, right? So it cannot be recognized by our network card. Problems easily. Therefore, in Cat6a and higher specification cables, besides the outer jacket, and the internal braided shielding layer, each twisted pair, as we mentioned earlier, a twisted pair cable has 8 wires, right? Every 2 wires are twisted together. So there are 4 pairs in total, right? Each pair of wires has its own separate shielding layer. The main purpose of this shielding layer is to prevent signal interference between this wire pair and the next. It prevents signal interference. There is also an overall outer shielding mesh layer for interference. For Cat6a and higher spec network cables, during production, you need to pay a little more attention. Inside here, there is actually a metal wire. This wire serves a grounding purpose. We need to take the weak-induced charge it generates and guide it to the ground. Release it to the ground. This way, we prevent the shielding layer itself from becoming charged. A magnetic field could interfere with the signal inside the cable. It causes interference. So when using these ultra-high spec cables, there are many precautions to take. This is the shielded twisted pair. Okay, in summary, unshielded twisted pair cables have no shielding layer inside, right? So their manufacturing cost is relatively lower. Therefore, if you don't have very high transmission requirements, right? Just for home use or for some small and medium businesses, right? There are no strong interference sources. And the transmission bandwidth, it's not right? Gigabit. Typically, many small and medium-sized enterprises use gigabit to the computer, to the desktop, right? In this case, we can adopt lower-cost cabling. Use unshielded twisted pair. For example, use Category 5e unshielded twisted pair for cabling. In this way, your overall cost is relatively controllable. As for shielded twisted pair, generally speaking, we will use it in environments with high cable speed requirements. For example, some 10 gigabit links. 10 gigabit link. Then we may need to use shielded twisted pair. Of course, when we transmit here between our network devices, in many cases, it is quite close. Even in our office scenario, the distance from our desks to the server room is, most of the time, not very far. usually about 20 to 30 meters. In this case, Category 5E can also achieve 10 gigabit. It can also achieve 10 gigabit. Because we say Category 5E can transmit gigabit, right? This standard is actually relative to a 100-meter transmission distance. When the distance is shortened, the electrical signals on this cable, right? The interference between them, when the distance is relatively short, the interference will be relatively less. So it can better adapt to our high-speed links. So it's not necessarily true that to transmit 10 gigabit, you must use Category 6. Or even Cat 6A or similar cables. Not necessarily. If your distance is less than, we've tested it before. If your distance is less than 31 meters, then you can actually use Cat 5e to run 10 gigabit. Of course, if you can use shielded twisted pair, that would naturally be better, right? Okay. So here it's about network cables. Some categories of twisted pair cables. You need to understand these. Generally speaking, like the Category 5 twisted pair we mentioned here, it's used for 100 megabits per second Ethernet transmission. Right? These standards are actually all based on 100 meters. Based on and also, its wire gauge and materials must meet national standards. Only this kind of network cable can achieve it. Because currently, online, you often buy things. Right? Buying network you often like to buy them on when buying at the time, very often. It's easy to get ripped off by dishonest sellers. There are many tricks here. For example, the network cable. The copper wires inside are very, so they often will make the copper wires in your cable thinner in diameter. After making the wire diameter thinner for a whole roll, generally, a standard net comes in a box, which is 305 meters. 300, so, after thinning it out, they can save a lot of copper. Right? So the biggest cost in a whole box is actually the copper. In that case, you will buy some relatively cheap network cables. Right? At this point, there's a very high probability that it might occur where the wire and also, they swap out the medium in the middle for you. We call it a copper medium, right? What might they swap it with? Aluminum. Swapped to aluminum, whose conductivity is actually okay. Compared to copper, it is certainly, but compared to other metals, aluminum is cheap and light. Right? And then, its conductivity is at this point, many just love to take that medium in the middle and swap it with aluminum. Then they coat the outside with a layer, plating it with this copper. Right? When you strip the cable jacket, at first glance, it's golden yellow. Right? But actually, if you scrape it a bit, you will find the inside is actually white. This is exactly copper-clad aluminum. That kind of in this case, because the resistance of aluminum relatively is higher than that of copper. So when you use this copper-clad aluminum cable, Cat 5, when you try to run at 100 meters, you'll find it may not transmit at 100 or Cat 5e. When you run at 100, it won't transmit at 1000. Of course, there are many other things. They simply don't even use aluminum. They use iron made with iron wire. Then the resistance is even higher. Right, and this might not reach 50 meters. This can't transmit data at all. This is very troublesome. So when purchasing these network cables, be extra cautious. Don't be cheap and buy some. These cheaper network cables. Generally speaking, these cheap network will have problems. Okay. Generally speaking, we, in campus network or enterprise networks, when using these cables, generally using them at 10 gigabit is about right. A transmission rate of 10 gigabit is about right. If you need to use 40G, 100G, or even 400G, generally, in this case, we will use fiber optics instead of network cables. Because fiber optics, its transmission bandwidth is larger. And also, the cost will be low. Okay. So, network cables. This is just a cable. We need to put a connector on it, so we can use it properly. When making network cables, well, we need follow the corresponding wire sequence. You can't wire. Some students might. I can just make both ends the same sequence. Right? As long as the order is the same. It seems to work if both ends are wired the same. Right? It does work indeed. However, if your environment is harsh, or if the transmission distance is quite long, when we need to reach 100 meters, at that, if you didn't follow the standard wire sequence to crimp the RJ45 connector to make this network cable, then it's very likely you won't achieve our standard speed. For example, you want to achieve, right, gigabit at 100. If you didn't follow the wire sequence to make the cable, then very likely you cannot reach the 100-meter distance. Because the interference will be severe. The interference, As for our wire sequence, you need to remember there are two types. Actually, you only need to remember one. The one we use most often is actually the 568B standard. We use the 568B standard. The wire order, this wire order. You must memorize it. Learn it by heart until it's set. Yeah, there are different ways to remember it. Right? My usual way to remember it is orange, green, white, blue, white, brown, white. Okay, that is the wire order. So, whenever you crimp an RJ45 connector, just recall this in your mind. This wire order. Right? Okay, and then, following this sequence, in your hands, line them up proper. Okay, line them up, and okay, now, the corresponding 568A standard, okay, is basically taking, and, the green, pairs, and swapping them with each other. Right, just swap them with each other. For example, swap white green with white orange. And swap green with orange. Okay, and then, swap white orange with white, okay, and then, swap orange with, right? Okay, it's exactly, so this is our 568A. 5-6. Now, when you make cables in practice, hey, there are two ends. One network cable, right, so when you make it. Actually, currently, we only need both ends as 568B. Terminated as 5, that's all you need. No need for one end A and one end B. This is actually some legacy tradition passed down on older equipment. We might need to use a crossover cable with 568A on one end and 568B on the other end. Right. What is a crossover cable? It means one end is 568A. The other end is 568B. These two different wiring sequences to make this network cable. We call this a crossover cable. We call this a crossover if both ends are 568A or both ends are 568B. Then we call this a straight-through cable. Straight-through cable. Of course, there's a very special cable type called a rollover cable. Rollover means the wire sequence is completely reversed on both ends. The wire sequence is complete. So this one is mainly used to manage network devices. A console cable. This is not a communication cable. It is specifically used to configure network devices, like switches, and you need this type of cable for these devices. As for the console, we will cover it separately later. Don't worry about it for now. You just need to remember this. Just get familiar with it. Now, regarding 568A and 568B, spend some time after class to memorize the 568B pinout. You must memorize it thoroughly. Know it by heart. Recite it backwards and forwards. Never forget it. Okay, generally, the maximum theoretical transmission distance for a network cable is 100 meters. Can it work at 101 meters? Actually, in many cases, if the cable material is not substandard, then 101, 110, or even 120 meters is possible. All are possible. Of course, if the materials are, the distance will be reduced. For example, 80 meters. If it exceeds 90 meters, it might fail. Then, degrade in speed. So, buying a cable that meets national standards. Twisted pair cable is very important. This prevents various strange problems during your projects. So, how do you make a network cable? To make a cable, you need a few things. First, the cable itself. Second, the RJ45 connectors. Third, a crimping tool. Fourth, a cable tester. We call it a cable tester. Of course, if you are an experienced network engineer, you can do without a tester. You can do without it. For example, I rarely test my cables. Every cable I make work. In that case, you don't need the tester. Once you are skilled, you won't need it either. But when you are just starting out, I still recommend having one of these to verify whether the cable you crimped works or not. To check if there are any lines, check if these things have it. This is very important. So, the first step. The crimping tool has a groove. Place the cable in it. After rotating it once, you can strip the outer jacket. Of course, there is also a dedicated stripping knife. A dedicated stripping knife works too. Anyway, just strip the outer jacket off. What is the recommended stripping length? 16 millimeters. 16 millimeters, though you can strip a bit longer. Especially for beginners. For your first time or first few times making cables, I suggest stripping the jacket a bit longer, because it makes it easier to arrange the wire sequence later. It makes arranging the wire that's relatively simple, right? If you leave it very short, the wires might get messed up while you're arranging them, right? That would be inconvenient. After stripping 16 millimeters, because they are twisted pairs, every two wires are twisted together, right? First, according to the wire sequence. First, untwist all of them. Then, following the sequence, line them up one by one. Line them up one by one. After lining them up, take the crimping tool. The crimping tool has a dedicated cutting position. Use the dedicated cutting position to trim them flat. Trim the front end flat. After trimming it flat, take the RJ45 connector. Take the RJ45 connector has several faces, right? Notice the side with the copper contacts. That side with the copper contacts faces you, faces yourself, faces yourself. Then, the far left side corresponds to the far left copper contact. Corresponds to the white-orange or orange-white wire. The rightmost pin corresponds to the brown wire. Face it towards yourself. Then from left to right, white-orange, orange. White-green, blue, white-blue. Arrange the wires in this, trim them flat, and then face the copper contacts towards you and push it in. Push it all the way in. Be careful, you must push it all the way in. So, when trimming the wires just now, everyone needs, why did I just ask you to? When stripping the outer, leave a length of 16 millimeters? Why leave exactly 16? Because the length inside the RJ45 connector is limited. If you strip too much of the jacket, and then, after organizing the wires, you trim them, if the exposed length here is too long, then when you insert the cable and lock it, after crimping it with the crimping tool, you will find that the outer jacket is actually not crimped into this area. This area is a plastic retention clip. According to the standard, we must crimp the outer jacket into this plastic clip. This way, it provides a strain relief effect. If you fail to crimp it, everything relies solely on the front copper contacts to hold our cable in place. In that case, the pull resistance is definitely worse than crimping the jacket. So, when trimming the cable flat, you must leave the right distance. Leave the right distance, about 1.5 centimeters or so. 1.5 centimeters is roughly 15 to 16 millimeters. After inserting it, crimping it just right allows the plastic clip to clamp onto our cable's outer jacket. The twisted pair cable's outer jacket. And in this way, a standard RJ45 connector is properly crimped. The RJ45 is crimped. Actually, that's the termination for Cat5 and Cat5e. If the network cable, the twisted pair, we are using is Cat6 or even higher, like Cat6a or Cat7 cables, the termination method is different. The termination method is different. Even the connector itself is different. And this connector, well, we call it RJ45. This connector is called RJ. Then, for our telephone line, we call it RJ11, RJ11. So, what I'm showing you here is how to terminate an RJ45 crystal connector. As a network engineer, you definitely need to know how to terminate cables. Whether you actually do it in the field on a project, that's one thing. But knowing how to do it is another. Right? When you go out, you're a network engineer, and you don't even know how to that would be inexcusable. Okay, then, as we just mentioned, when terminating crystal connectors, there are straight-through and crossover cables. Right? So why does this distinction exist? If both ends use the same wiring standard, for example, both are 568B, both are 5, then we call this a straight-through cable. Or if both ends are 568A, it is also called, then, one end is 568B and the other is 568A. This we call a crossover cable. Right? So why does this happen? Well, we all know that when transmitting signals, there is a distinction between sending and receiving. Right? So, in a straight-through cable, This represents sending. And this side represents receiving. So your electrical signal goes over like this. And then this one is the negative signal. This is a positive signal. Note how we transmit a signal inside a pair of wires. For example, inside this pair of wires. It's not that one side sends a signal and the other side sends back. It doesn't transmit. No, it doesn't transmit that way. When transmitting, one wire carries a positive signal. The other carries a negative signal. A positive signal and a negative. Why transmit it this way? This provides anti-interference. Note, remember, in network cables, in twisted pair, anti-interference is a very important topic. If we inside a network cable, one wire transmits a signal, and this one transmits the reverse signal. Transmitting this way, if a high-frequency magnetic field is generated here, causing interference to me, at this time, the voltage on both sides could change. The voltage between the two ends could change. After the change, the transmitted signal may differ. So why do we use a pair to transmit one signal? Use a pair to transmit one signal. One with a positive signal, the other a negative signal. Then we calculate. We calculate the difference between these two voltages. The difference between the two voltages. If I apply a high-frequency magnetic field interference here, at this time, either both voltages rise together, right? Or my voltage drops at this point, the voltage difference between our two wires doesn't actually change much. This provides an anti-interference effect. So, when using straight-through and crossover cables, it mainly depends on the devices at both ends. It depends on how these 8 wires are defined for use in the twisted pair cable. The definition of their use. If both ends define the orange pair as the receiving wires and the green pair as the transmitting wires. If that definition is used, then on this side, the orange wire is for transmitting. This side transmits. And the far end, this side receives. Right? One transmits, one receives, they match up. But if both ends define the orange pair as receiving, the signal might not be able to transmit at all. Right? And if green is defined as transmit, then I transmit and you the signals will interfere with each other. This creates a collision, right? So it cannot be used this way. There, you need to use a crossover cable. Specifically, the orange and green pairs are crossed over, right? They cross over with when my side transmits. The corresponding side is set to receive. The pins are pins 3 and 6. What about pins 1 and 2? They happen to match my transmit pins. And then, on the other device, they match its receive pins. That's why we use a crossover cable. This one, it's actually from our older environments. From older environments. It doesn't support wire sequence flipping. It doesn't support auto MDI/X. Our newer devices, however, actually support auto MDI/X. Whether you use a crossover cable or a straight-through cable, it can actually recognize them automatically. And then, it automatically adjusts the pin functions. The function of it adjusts automatically. In the network cable just mentioned. Actually, pins 1, 2, 3, and 6. Inside, the orange and green pairs transmit and receive signals. The remaining pins, 4, 5, the blue and brown pairs, they don't transmit or receive. Right? This transmission mode is actually our older transmission mode. So when using it, if you only need 100 megabits, you only need to terminate 4 wires. So in some projects, some engineers take right? They split one cable into 2. Split into 2 to achieve 100. If you want to achieve gigabits with gigabit, all 4 pairs transmit and receive simultaneously. So all 8 wires must be used. And the wire sequence must be standard. If it is not standard, the 100-meter transmission distance may not be achieved. When we use crossover or straight-through cables, right? So what about, the general rule is this. If the devices are not the same type, for example, one side is a switch, and the other is, or a hub, connected to our PC, right? In these cases, we use a straight-through cable. Because their pin assignments are different. When one side, the other side receives, so we just use a straight-through cable. If they are the same type of device, for example, both are switches, then my pin assignment and your pin assignment might be the, right? So when my side, your side is also transmitting. In this case, we need a crossover cable. We need a crossover, right? Of course, this is all the old convention. Currently, for all our crossover needs, the ones you can see on the market, the devices you can buy, all support auto MDIX. They all support auto MDIX. It can auto-negotiate. Once it detects a signal conflict on both sides, a potential it will auto-adjust. Then it connects with the other side. Therefore, currently, when we use it, we can just use a straight-through cable. Both ends use 568B. Just use 568B and you're done. Okay. So, why, in real-world projects, do we still actually use copper cables, meaning Ethernet cable? There are several reasons, especially for end-device access. For end-device access, we mostly still use copper cables. That is, Ethernet cables. There are several reasons. First, our end devices. Very few currently support a direct fiber optic connection. Like your computer, right? A laptop or a desktop. Very few have a port to directly plug in fiber. Right? Yeah, they all use Ethernet. Some laptops don't even have an Ethernet port. You need a docking station. Right? Okay. What else? Like some surveillance cameras? Things like, right? Yeah, they also use Ethernet cables. Fiber is for the end devices. There are some limitations. Besides the lack of support on end device interfaces, there is another reason. Some of our devices, as we covered PO technology in the last lesson on network devices, right? Transmit our electrical signals via Ethernet cable and also provide power. Provide energy. Right? For example, these 4 lines 4, 5, 7, and 8 don't transmit signals anyway, right? Under that scenario, they don't transmit, so at this time, we can use these 2 pairs to transmit our voltage. To power the device, to provide power for, Of course, different PO standards have different pin out. So when you're running you can't just crimp this is the reason why you need to memorize, you can't mess around, What we just discussed is our copper medium. The second module is fiber optic. Now, hey. Many people this fiber optic, many students might not have relevant experience. Many students might, right? The only experience, right? To splice your fiber, then connect the right? That's just one you rarely encounter, however, fiber optics are actually, especially in data, in the same data set, or within the same, when we connect cables between them. Very often, we use fiber optics for the connection. This has several benefits. First, the cost of fiber is relatively low. It's relatively low because the core primary medium inside fiber is glass. It's glass strands. Right? Now, this glass strand material, it's everywhere. Right? It's basically quartz sand. Right? Just yellow sand. Right? It's very abundant so the cost is quite low. The second reason is that in a data center, generally, our core devices have very large transmission bandwidths. For example, 10 gigabit. This is quite common. Then, starting from 40G, that also exists. Even 100 or 400G. For these high-speed link bandwidths, this is also available. In such cases, if you still use copper cables, right? First, its interference can be quite because our switches on the devices, when connecting, it's not just one cable. You don't just plug in one. Basically, will probably populate every port. So, cables will be very close to each other. They'll be packed. As a result, if you use Ethernet cables, the mutual interference will be quite severe. But fiber optics, it doesn't generate a magnetic field, right? Because it transmits a light signal. It transmits a light signal. Therefore, its anti-interference is actually quite strong. When doing extensive cabling in the server room, during large-scale cabling, fiber optics works much better. You don't need to consider the issue of how many cables can fit inside that problem, right? Also, compared to Ethernet cables, specifically it's thinner. Easier for cable management. Easier to make the cabling look neater. Right? But what's the use of neatness? It makes it easier for the client. The one who's paying the client, right? This is more satisfying. Right? Acceptance is easier to pass. Make it look nice, right? Because many people don't understand, right? What they can see is whether it looks good. Right? Looks good and works, then acceptance is passed. Right? Works well but looks bad. Then they might ask you to redo it. Right? Okay. So, besides these advantages, there are actually many. For example, our transmission distance. The transmission distance of fiber optics is much longer than copper cables. Especially our single-mode fiber. When it transmits, it is all counted in kilometers. Our copper cables, the maximum the theoretical is 1, right? So for single-mode fiber, generally it is calculated in kilometers. So many right? Like our submarine fiber, pulled from the US to China. Right? Of course, it has optical amplifiers in between. Devices that amplify the optical signal again. You can just imagine. Can you do that with copper? You'd need a signal repeater every 100 meters. That cost would be very high. And it's prone to failure, right? In short, optical fiber has many advantages. That's also why in our server rooms, we heavily use this optical fiber. Optical fiber is divided into single mode and multi-mode. These two types. So what is single mode? And what is single mode means? Within a single optical fiber, we transmit one optical signal. Inside the fiber, we only transmit one optical signal. So, with one optical signal, its light path is relatively, right? The path light travel, we call this this light path will be simpler. Meanwhile, we all know light scatters. Right? Scattering occurs. So if you only have one beam of light, one frequency of light entering, then its scattering condition will be greatly reduced. Right? Greatly reduced. Therefore, single mode suits long distance transmission. Long distance transmission. For example, several kilometers. Right? Tens of kilometers like this. Its emission uses a laser for transmitting. It requires the use of a laser. Because we all know that a laser is monochromatic. When emitted, the light has only one wavelength to prevent other signals. Right, from impact transmitted data. Right, so when using single mode fiber, it uses a laser as the light source. So, the other type is called there's a typo here. This is called multimode. Compared to single mode, multimode actually refers to transmitting multiple optical signals within a single glass strand. Transmitting multiple optical signals. So, its requirements are relatively higher. First, the glass core. Right, this core has a much larger diameter. Look, in single mode fiber. Right, its core is only 8 to 10 microns. About the size of a hair. As thin as a hair. Or even thinner than a hair. So, for multi-mode fiber, its core reaches 50 to over 60 microns. That is much thicker. Right, not in the same order of magnitude. Then, because we transmit multiple optical signals. Right, light signals can interfere. Therefore, multimode has a shorter transmission distance than single mode. Relatively, generally speaking, it's a few hundred or 1 kilometer. This range is usable. But generally, multimode is mostly used for internal patching in the data center. Patching from one cabinet to another. Or within the same cabinet. Right? Patching between different devices. In this case, it's generally just, right, a few meters. This isn't a big issue. So, for multimode, because it needs to transmit multiple optical signals of multiple wavelengths. Right there, its light source. The light source uses an LED. Compared to a laser, this LED light source costs less. The bulbs in your homes, right? These are LED, very cheap. Right. So, this bulb, multimode is relatively cheap. This is why, when patching inside a data center, it's the most used type. First, its transmission is actually sufficient. A few hundred. When patching inside our data, it's enough. Second, its cost is relatively low. Where is the cost mainly concentrated? Mainly in the modules. Note this, fiber optic cables are not plugged directly into our switches. They need to be connected to a fiber optic module. They are also divided into single mode and multi-mode. The main function of a fiber optic module is to emit and receive light. That's its purpose. For our switches, inside a switch, if you buy a fiber optic switch, right? You'll find they are all, right? The ports are all empty. You have to plug in you must insert these optical modules. And multi-mode modules are cheaper than single-mode modules. The core reason for is their different light sources. Multi-mode uses LEDs, which are cheaper. The manufacturing difficulty is lower. Therefore, it is cheaper. In this case, overall, our usage cost is reduced. Right? Okay. That is a basic classification of fiber optics. When using fiber optics, you must pay attention to the transmit and receive direction. If one side transmits, the other side must receive. If this side the opposite side, both sides must correspond. They must correspond. Of course, there is also transmission over a single fiber core. Then we need to consider other issues. For example, single-mode fiber. Single-mode fiber is usually yellow, right? Multi-mode fiber is generally orange. Of course, different specifications of fiber optic cables have different colors. Okay. And we just mentioned optical modules, right? The most common are actually this one and this one. These two are more common. SFP plus optical module. What does SFP? It refers to our 10 gigabit. 10 gigabit, meaning a 10G interface. If it's SFP without the plus sign, it refers to a 1G interface. A 1G interface with a plus sign, it is 10G. And Q. Q stands for quarter. Right, meaning 4 times. Then, it's followed by SFP plus, right? SFP plus is 10 gigabit. So 4 times 10 is a 40G interface, right? So this is a 40G interface. This port is used to plug in our fiber. Some have 2 ports, some have 1 port. This depends on the connector of our fiber. What type it is. This section covers basic fiber optic knowledge. Later, I will share some project engineering, network engineering basics. Some equipment. Let's get familiar with some tools. First is our cable tracer. Especially for network retrofit projects. Network retrofit project. It's not a complete, it modifies at this point, you probably need to find this network cable. Right? How is it routed? For example, at this workstation. Right, there is then, where does it connect in the server room? At this point, we can use a tone tracer to find it. This end can plug into our network cable. And this module can be detached. It is clipped together in the middle. Right, you unplug it. Hold this handle. And follow the cable to the server room. Sweep each cable one by one. When you scan the matching cable, it will emit an audible signal. Then you know it's this cable. Right, this way you can find the exact location of that cable. This tool is specifically for finding cables. Of course, this method won't work. Okay, then the cable tester. As I just mentioned, after you crimp the cable, right, plug one end here, and the other end here. Then turn it on. It will start lighting up one by one. Essentially, it tests continuity. Right, it tests if it's connected. This end sends an optical signal. Or an electrical, if the wire conducts. If it is conductive, Then the corresponding, it will light up. If you crimped the wrong, then position 3 might light up. Right, this allows you to quickly judge if your cable crimping is correct. If it's crimped correctly. Here, you may note a G marking here. The G marking stands for ground. This refers to grounding. When we crimp some Cat 6A or Cat 7K, we must pay attention to this grounding wire. This wire, right, its connection, right, requires a specific RJ45 connector to crimp. You must use a shielded RJ45 connector. Press this wire into the shielded connectors. Rear dovetail, press it in firmly. This way, we can discharge the static electricity into the ground, right? When testing these cables needing static protection, these shielded cables, you need to test this G will also light up. For unshielded cables, only the first 8 lights will flash. They light up one by. This is the cable tester. Now, regarding fiber optics just mentioned, there is a minor point, that is the fiber optic connector. The fiber connectors you usually see are probably these. In daily life, you likely see this type. The SC connector, right? This SC connector is the one used on, it is basically the standard. We call it a square connector. Its port is square-shaped. There is a ceramic ferrule in the center. Right? Then plug it into your optical modem. You can go check at home. Unplug it from the optical modem. Be careful when unplugging it. This is called a square connector. There is also an LC connector. The LC connect, mostly used on our optical modules. It has 2 cores. One for transmit, one for receive. You must match them. Do not plug them in. Understand? What about LC? We call it the small. It has 2 cores, right? Relatively speaking, it is smaller than this LC connector. Each connector is slightly smaller. It matches our optical module perfectly. The optical module also has 2 ports, right? One for transmit, matching the transmit and receive on the other side. The ST and FC connectors at the back are generally used in surveillance and security for making RJ45 connectors and terminating surveillance cameras. In these kinds of play, they might be used, but they are relatively rare because this is a metal clasp. In some engineering projects, inside some factory buildings, during these factory projects, there might be some vibrations and other kinds of interference, such as temperature, humidity, etc., and other impacts. Right? In that case, we need more secure connection methods for the interfaces. For these types, some use a metal clasp to lock it in. Some screw on directly with threads. This makes it very tight. Right? So slight vibrations are less likely to in our datacom and enterprise network environments. These are quite rare, okay. So, at different transmission rates, we need to use different media. Make sure you understand, generally speaking, for gigabit and below, we recommend using Cat 5e or better cables. Cat 5e, Cat 6, Cat 6a. Generally, Cat 5e is enough for gigabit. Use standard Cat 5e. National standard Cat 5e. If you're not confident, you can buy Cat 6. A slightly higher spec, right? Even if it's a bit substandard, it's not a big issue. It can still deliver gigabit speeds, right? If you need to transmit 10 gigabit, we suggest just go with fiber optics directly. Use fiber optic. You can search online about this. A 10 gigabit switch. A 10 GBE switch with electrical ports, meaning RJ45 ports, versus a switch with fiber ports. Check out the price difference. The price difference is huge. The switch with fiber ports is cheaper. It is cheaper. You also need to buy optical modules separately. After factoring that, the total cost might still be lower than using copper cables. It can be more cost. Copper cabling is actually very expensive. Don't underestimate copper cables. National standard Cat 5e or Cat 6 cables are very expensive during installation. Fiber optic cable is actually very cheap. A kilometer might only cost tens of dollars. Right? Try buying a kilometer of copper cable. It will cost you over $1,000. So for very long distances or high demand scenarios, We recommend using fiber optics. Because fiber is even including the cost of optical modules. It doesn't cost much more. Okay. Next, let's talk about optical to electrical converters. You actually encounter these converters in daily life. That's your optical. Its job is to convert optical signals to electrical signals. That means converting, then connecting it to your home router. Right? Or you can connect it directly to a computer. It's a standard optical to electrical conversion device for home use. Right? Besides the optical, it actually has a specific name. We call it an ON. That's the term used in transmission networks. Our FTTR. Fiber to the room, right? They put an optical modem in every room. Actually, that thing isn't called an optical modem. We call it an ON. It's just called an. Then there's another type, which is an optical transceiver. An optical one side is for plugging in fiber optics. The other side is our Ethernet port. Right? That also converts optical and electrical signals. It's commonly used in surveillance and security. Used quite a lot. For example, for long-distance transmission to surveillance cameras. Say you need to run a camera 2 kilometers away. Or over a kilometer, right? If you pull an ether, you'd need 10 segments, and you'd need a signal amplifier between each segment. Or add a switch, right? That's very troublesome. So you use fiber optics, right? Pull it a kilometer. Pull it a kilometer. Then use these optical transceivers at both ends, right? Plug the fiber in a kilometer away, use another transceiver on its fiber port. Then run an Ethernet cable out to our device. This side connects to our switch. Then it's all set, right? The middle mile. The middle mile. This connection method. It saves costs. Saves costs. Another type. For instance, connecting to some servers. Or to your computer. They might not have a fiber port. You can't plug in this network card. Right? Can't plug in a net. In that case, you can only plug in that case. What to do? Use a media converter. A fiber to copper converter module. Its appearance is very similar to the optical modules we saw earlier. Not just similar, it's basically the, except the cable plugged in here is different. Everything else is this, right? So this is a media converter. It's used to connect devices that can't take optical modules. Like some firewalls or routers. The router might lack an optical port. Only having electrical ports, meaning Ethernet ports. Right? In this case, you must use a fiber to copper converter like this. This module is quite expensive. Much more expensive than this one. Also pricier than optical modules. Okay. Next. Some key points about using fiber optics. You should know about. One is called an OD, also known as it's also called a fiber termination box. It has many names. Many people call it different things. Right? Its main function is. It's basically for splitting. And also. This is for cable management. This is quite common in the telecom field. From the telecom access room. Right? A fiber optic to this ODF, and then the fiber is split into many fibers. Right? Connect them one by one. Each green layer here is a tray. And inside a tray, through a splitter. A splitter is basically a prism. Right? Through the prism, dispersed. Split into several, right? After getting these each one is distributed to this fiber port. Then from this fiber port, it's pulled out again. Pulled out one by one from this port. Right? So it's essentially a light splitting device. At the same time, it's also for managing cables. For managing our fiber optic cables. Because optical fiber, when installing broadband, the technician has, right? Don't bend the optic, it needs to be, right? You can't bend it, unlike network cable, where a slight bend is, right? It's very brittle. Don't bend it random, right? So in this case, we need to manage the excess, right? You can't get it exact, you can't use every, right? It might be a bit too, if it's too long. Just coil it inside, so it's used like this. On one side, this is our switch. Right? The fiber cable connects to our fiber termination box. Between the fiber, there will be a fiber, right? This fiber cable is for our switch. Right? The fiber cable connects to our fiber. Between the fiber, the cable runs across the optical cable, the optical cable, and on this side, right? Then connect to different, for example, or connect to our, such a module. Or a media convert, right? Ah. In short, that's how it's done. In this way, we can transmit, for example, in a campus network, right? From one building to, it might be arranged, and in between, we can use fiber optic. This is more okay. Now, when using fiber optics, as I just mentioned, you cannot bend them, right? Because the core of the bending angle, if it's too sharp, it might just snap. If it snaps, then the opticals at this broken because when it a single fiber, a single glass strand, right? When it breaks, it's so perfectly flat cut, right? If you look under the broken point inside actually has many jagged edges, right? It probably looks like, so your optical will experience refraction. It might experience refraction. And then, your signal will all leak out from here. All the light will leak out from here. So, fiber you absolutely can, when bending. Be a little careful when coiling. But they're not that fragile. Don't bend it excessively. Right? For example, 1.6 mm and 3 mm fiber optic cables. Their tolerable bend radius cannot be less than 3.5 mm. This distance, 3.5 you cannot go shorter. 3.5 centimeters is actually very close. Right? So besides saying that you cannot fold it, and cannot bend it bending is actually okay. It's not that strict, right? But these two actions definitely need attention. You must never pull fiber optic cables. Pulling. Because it is rigid. Everyone knows glass, its stretch. Elasticity is not, right? Unlike rubber. Or copper metal which has strong elasticity. Right? Glass has very weak, so if you pull it, it will break. It breaks when pulled, And squeezing is also an issue. Especially, for it, right? After you enter there are rows of the cabinets have doors, right? Sometimes you carelessly manage the cables. Right? And they happen to hang out, then you close the door, and the fiber optic cable gets squeezed. Right? That squeezing will likely exceed its bend radius. And then it breaks. It breaks again. Right? So, pay a little attention to this. Okay. So, that's all. In this lesson, we learned about the categories of twisted pair cable. Right? It's mainly divided into coaxial cable. Twisted pair is further divided into shielded and unshielded. Right? And some basic knowledge about network cables. Right? The 8 wires inside, right? The 568, you need to memorize this after class. And then, how to crimp RJ45 connectors, etc. Right? For students who have, you can practice you can give it a try. And the third point is, some basic facts about fiber optics. Right? It's divided into single mode is generally suitable for long distance transmission. Multi-mode is suitable for patch cords inside the server room. Right? Its cost is relative, and when doing network projects. During network some common practices. And an overview of some tools we often use. Right? So, that's the content we covered in this lesson. So, for this we'll stop here.